So for week 14, we're going to have the final project presentation. So for this, remember from last week, we talked about I was going to use the Titanic data set. I've made a proposal, and in that proposal, I went into quite all of the steps which I'm going to use in my final project. So I'm going to just use the exact same document that I had previously, and I'm just going to build on this document and add in results from the study that I did. What you're going to do in your case is you're going to turn in your analysis document similar to what you see here, updated with the new information as well as your Jupyter Notebook. So I'm going to spend most of today talking about the Jupyter Notebook part of it. So here I built a brand new Jupyter Notebook. I'll have the same exact sections for business understanding, data understanding, etc. And I have copied over some of the information which I brought from the document. So this is a quite common way of handling this. The actual Jupyter Notebook could be used to drop off to PDFs, to save out to PDF. And so that's why this is going to kind of, all the code is going to be encased in it. So here you're going to see very similar, all the stuff which we had previously. And then here in this particular cell, this is where we're going to start the code. So first of all, I'm going to import all of the libraries which I'm going to use. In this case, I'm going to use pandas. I'm going to use matplotlib. I'm going to use requests. I'm going to use requests in order to get the URL so I can download the data directly to my data set, to my data frame. And that's also where I'm going to use I/O, the I/O section of it here for the string I/O piece. And then I'm going to basically focus on sklearn. And sklearn, I'm going to use the impute library for imputing missing values, pre-processing, the model selection for the train test split part of that. I'm going to take a linear regression and I'm going to take a decision tree classifier. So then these are all within the sklearn. There's the linear model subsection and the tree subsection. So I'm going to do both of those two. And then for the metrics, I'm going to look for the accuracy score, confusion matrix, ROC score, area under the curve for the ROC score, and the precision recall. So you're going to see all of the pieces of this as we get down into the code. So again, for this first particular section, we're going to just basically read it from a URL and stick that into a pandas data frame called data. I'm going to display some summary statistics right off the bat. Check to see the data types for the columns, making sure that that's good. Looking for the number of null values and then exploring some of the unique values on top of it. So I'm just going to do some of those pieces right there. And then I'm going to put this into a plot just to make it really easy to see. So right here we can see distribution of age, for instance. I'm going to see the vast number of people fell into that 20 to 30 range, or maybe 20, 30, 40 range. So that could affect the type of study that I want to, the type of modeling that I want to do out of my study. So then the next thing is distribution of fair. We can see that there is a couple different classifications of fair. And that's pretty much an initial just look at the data, which I did there. Next thing is I'm going to go into the data preparation stage of it. So here's where it's going to do some things that you would want to do inside of yours. First of all, I'm going to drop some columns, passenger ID, name, ticket, and cabin. Not going to need those. So by using the data frame function of drop, list the columns in the axis, and there I'll drop those irrelevant columns. I'm going to take the missing values and I'm going to fill them in with NA. So that's what this function is doing right here. And I'm going to do that in place. So taking age and embarked and filling those in. I want to convert the gender, the categorical variable for gender, to show a male or a female, but I want to have it as either 0 or 1. And that's going to help me later on when I start doing some of the plots and the other things, and the analysis and the modeling. I'm going to put in missing values for embarked and age because we knew that they had some. I'm going to put those and do the transformation right here. And then I'm going to do some feature engineering. I'm going to make a family size and an is alone by applying some functions to it as well. Categorical variables. So I'm going to get dummy for variables for data frame. for sex and embarked, drop the first, put it in there as true. And then I'm going to scale the numerical variables, age, fair, and family size. I'm going to split that into X and Y, features and target. And again, we're looking at the survived part of this. So changing that into features and target. And then just as a good safety catch, I'm going to save that out to a CSV file called preprocessed Titanic dataset. Now later on in the code, we could load it. If we were just running individual pieces of it, instead of having to run the entire code, you could then pick up that preprocessed Titanic dataset and you could load that. By the way, I will include this entire Jupyter Notebook, the document, as well as this little CSV file so that you can take a look at the results too as well. Simply running this Jupyter Notebook, though, it will generate one of those for you. But if you would just be interested in seeing what the data looks like in the raw format, you can just look at the CSV. Okay, so then in the EDA section right here, this is where we're going to use Seaborn, and we're going to do some plots. So survival distribution, age distribution by survival, survival by passenger class, survival by gender, and then the fair distribution by passenger class. First of all, the number that survived versus the numbers that did not survive. Age distributions of those that survived versus did not survive. Passenger class of 1, 2, and 3, those that did survive and those that did not survive. Gender, so male and female, those that did not survive versus those that survived, which is an interesting piece of data to take a look at because, again, we talked in the initial considerations, we were thinking the women and children first would cause this type of an issue. Should see more females survived than males survived. So that could also indicate maybe I did something wrong inside of my assignments to male or female. So as a good safety check, I would go back and I would double check my code to see if male and female were correct. So that's an interesting little hint which you should check out if you're interested. Fair distribution by passenger class, and you can see that we do have some outliers here, which is interesting. Then we do the correlation heat map. So very similar to what we talked about with correlation maps. So we start seeing things that are interesting and things that have correlations. Weak correlations, no correlations, or negative correlations. We can all see that. Next step, we're going to go into the modeling piece of it. And so I'm choosing a logistical regression as well as a decision tree classifier. So out of this, I'm going to use the X and Y that we had. I'm going to drop out the survived, but then keeping the features data set and the target data set. I'm going to split that into training test by using this call. I'm going to then turn around and pull off a logistical regression and call the fit in order to create the fit using the two data sets, the features and the data target data set. Next, I'm going to evaluate the accuracy using of the logistical regression model. That's what we see down here as far as the accuracy of it. And so you can draw some conclusions just based off of this part right here. But let's go ahead and build a decision tree classifier as well. I'm going to go ahead and use the predict here in order to make the predictions, and then turn around and generate the accuracy score. So if we look at these two, relatively the same, the logistical regression model and the decision tree model, both of which are relatively the same level of accuracy. Let's go into a little bit deeper of the evaluation though. So if I'm looking here, I'm going to first of all calculate a confusion matrix, looking of those that survived and looking to do that logistical regression. And then I'm going to do a confusion matrix of the Y true and Y predicted. And that's what I'm going to have as the confusion matrix. Then I'm going to simply run a Seaborn and Matplotlib, the combination of that to get the confusion matrix plotted. I'm going to then turn around and do a rock curve. And so by using the predict probe then you can do the exact similar type call with it. We then call the rock curve. and then we plot the rock curve. I want to also calculate the area under the curve. So using the AUC score, here's how you make the call to that, and just simply print that out. And then finally, a precision recall curve, looking at the precision, recall, and thresholds. Make that call. And so the interesting pieces are to look at the grid here, and we can see the confusion matrix, which again, the number of false positives, true positives, false negatives, true negatives are all outlined right here. False positive rate, and looking at the area curve, and you can see the area under the curve here as well. And the other thing I didn't do with my AUC, my rock curve, is I didn't produce a best line, and that would probably be one additional addition I would add to this. And then the precision recall curve as well. So then the next thing I go for the D-tree model, I do a very similar type calculation, and so you can see it's got a little bit more interesting receiver rock curve that's coming out of it. But probably a suggestion I would give to somebody if I was reviewing this was I would add the best fit line there too as well, just so you could see that. So that's the final project. In this case here, using the Titanic data set. Yours should be slightly different than this. It definitely wouldn't be using the same data set, but having those key elements of the CRISP-DM framework, want to make sure that you're using that. So if you have any questions, there'll be office hours and there'll be one-on-one sessions scheduled. If needed, reach out to your instructor. The instructor will help set up one of those one-on-one sessions, because this is really the last week that you'll go through and produce your final project. When you're done with your project, we would also ask you post it back out to the discussion forums so that the other students could see what you've done for your work, and they could evaluate, they could give you peer feedback on it as well. So those are the two pieces of the assignment you have to put together. If you've got any questions, please reach out. Have a good one.